Alright guys, welcome to our channel Code with Sunny, and in this video I will be talking about the third problem of daily LeetCode challenge January 2022. Okay, and today we are going to face an easy problem. Find the town judge. Its index is 997. Okay, so let's begin. In a town there are n people labeled from 1 to n, and there is a town judge also among these n people, and there is exactly one town judge. Okay, and if a town judge exists, then the town judge trusts nobody, and everybody except the town judge trusts the town judge. Excluding the town judge, any of the people is going to trust the town judge, and there is exactly one person that satisfies the properties 1 and 2. As I said, there will be exactly one town judge, and you will be given an array trust. Okay, so there will be some person is trusting some other person, and it will be represented by a n cross 2 matrix, and trust of I will be like a1 comma b1. It means that a1 is going to trust the person b1. Okay, and we have to return the label of the town judge if the town judge exists and can be identified with respect to these two conditions, these three conditions. Okay, and if it exists, we are going to return the label of the town judge. Otherwise we will return -1, denoting that no, there doesn't exist any town judge. Okay, so let's understand this problem with a example. Okay, so suppose that we have been given an array. Yes, we have been given an array. Let's pick up an example, it will be better. 1 3 2 3, like n will be 3, and that will be like 1 3. 1 is trusting the third person, and 2 is also trusting the third person. Okay, so you can see that there can be like exactly one, like there will be an exactly one town judge. Either it can be 1, or it can be 2, or it can be 3. Okay, so first approach would be doing the brute force and checking it out if the person 1 can be the town judge or not. If the person 1 is going to be the town judge, then every person except this person 1 is going to trust the person 1. That is 2 comma 1 must be an element of this array, and 3 comma 1 must be the element of this array, and 1 comma any of the element must not exist in the array. This is because, as you notice the problem statement, the town judge trusts nobody. So if 1 is the town judge, then you should not find any element like this 1 comma any element. You should not find anything like this one, because in that case our assumption that 1 is the town judge will not be satisfied, because this town judge is trusting some another person. Okay, and every person excluding this town judge must be trusting this person 1. Okay, so there must be an element like 2 1 3 1 4 1 and so on if there exist more elements. Okay, so how we are going to do this problem? If we are going to do this like a brute force, claiming that this person I is going to be the town judge, and checking it out for every other person, like we need to check it out that every other person excluding this current person must be trusting this town judge. In that case your complexity will be like O of n square. Okay, then you are going to get TLE. Why you are going to get this one, this verdict? Because you look out the constraints. Constraints. Yes, you can get a TLE because n is around 10 raised to the power 6. I'm not sure about that because I've not done this like this approach, but I think you should have to check it out. Yeah, you are also going to iterate for the every element of this pair, every element like ai comma b, and check it out that this pair is going to exist or not. In that case you may get a TLE. Okay, so I'm not talking about this like a bad approach. I will talk about how to convert this problem into a graph problem and find an efficient solution regarding this. Okay, so let's convert this trust array into some directed edges. How we are going to do that? Okay, so we have an array like this one, array ai comma bi. Okay, bi. So it means that AI is trusting this person BI. So I will draw a directed edge from AI to BI. Okay, and similarly for every element of this array, like a1 b1 a2 b2, like we are going to draw a1 directed towards b1, a2 directed towards b2, and so on. Okay, now we need to find the town judge. Okay, now consider this as like let's say the employee, sorry, not employee, person 5 is going to be the town judge. Okay, and there exist let's say 6 persons overall, and person 5 is the town judge. Okay, so what will be the, like if you imagine the graph, how the nodes should be connected, you can easily find out the efficient solution. Okay, now if 5 is the town judge, there must not be any directed edges outgoing from this vertex. If it exists, like if any directed edges outgoing from this town judge vertex, that is the vertex 5 person 5, then this person 5 cannot be the town judge. Why? Because you can see the town judge trusts nobody. If town judge is trusting some another person, then there must be an edge outgoing from this 5 to some another random person. Okay, so if person 5 is going to be the town judge, there must not be a outgoing edges going from this 5. Okay, now what about the another condition? You can see everybody except for the town judge trusts the town judge. Okay, so it means that there must be exactly n minus 1 directed edges incoming to this node 5. You can see I have taken total 6 nodes. So there will be 1, there will be 2, there will be 3, there will be 4, and there will be 6. Okay, so there will be exactly n minus 1 edges, incoming edges that are going to be incident on this node 5, and there will be no outgoing edges going from this node 5. Then the 5 node 5 person 5 can be claimed as the town judge. Also you can notice that there can be like a relationship of trust between 3 and 4, or can be 3 and 6, or between any nodes. But what we need to focus over here is that I am claiming that node 5 is going to be the town judge only and only when there exists exactly n minus 1 incoming edges to this node 5 and exactly 0 outgoing edges, directed edges from this node 5. Okay, also you can note that I am maintaining this AI to BI. Okay, that's why I am going to check it out the incoming edges, because we have already drawn the directed edges from the person first person to the second person, denoting that this person 4 is trusting the person 5, right? In that case, what we need to check it out finally, that there will be exactly n minus 1 incoming edges. It means that there are all the other people except the town judge is going to trust this town judge person 5. Then I'm going to say that yes, this person is going to be the town judge. Okay, there can be many like many town judges in this graph. If we are going to convert this problem to graph problem, then we need to report that if there exist more than one town judges, then we are going to return -1 as our answer. Otherwise, if there doesn't exist any town judge, again -1, and if there exists exactly one town judge, we are going to return the index of this town judge. Okay, so let's try to code it out as fast as possible. So I will copy this one, and actually I've already solved this problem, but I need to show how we are going to do this. Yeah. Okay, so what we are going to do is we are going to write down the, if we convert this problem to graph problem, then we should have for every node we are going to store the in degree and out degree, number of edges incident on it, and number of edges going out from the current node. So I will write vector int in degree, and there will be n plus 1, and out degree of n plus 1. Okay, and I will take out every edge, and first node will be like edge of 0, and the second node will be like edge of 1, and if there is an edge from 0 to like u to v directed edge, then I will say in degree of v should be incremented by 1, and out degree of u should also be incremented by 1. Okay, and what we need to check out the final, let's claim that index will like town judge, let me take a more specific variable, town judge, let's say it is -1, initialize with -1, and for every index I need to check it out if this can be the town judge or not. Note that we can do this in O of 1 operation. Okay, so if in degree of I exactly matches with n minus 1 and there doesn't exist any out degree of this current node, then I can say yes, this node can be the town judge. So if we have already found out the town judge, like town judge not equal to -1, and this is also the town judge, then there are more than one town judges in this arrangement, then we are going to return -1, else town judge is going to be the current index. Okay, and finally we are going to return the town judge. Okay, I think this should work correctly. Okay, so let me copy this and submit it. You can see I've already solved this problem, so but I've solved this with a different approach. Yeah, runtime will be this, and it is faster than this. There are many ways to solve this problem, but I consider this as the best one. So if you have any doubts, do let me know in the comment section of the video, and I will ask the viewers to like this video, share this video, and do subscribe to our YouTube channel for latest updates. Thank you for watching this video.